All right, I'm back and we're here with the beautiful Pascal's triangle, and we're going to show how we use Pascal's triangle to expand a binomial. What do I mean by expanding a binomial? Remember, a binomial is two terms, and if we expand it to the nth power, then it might be getting a little confusing. If it's the second power, you're just going to FOIL it and it's easy. But what if you have x plus y to the seventh power? That's going to be a little bit more difficult because then you're going to have to FOIL and FOIL and FOIL and distribute, and it's going to take you days. So let me show you a little shortcut of how to expand a binomial to the nth power. Just real quickly, this is what we're going to do. The coefficients for the terms are going to come from Pascal's triangle. The exponent that you are expanding it to is going to be the row that you use. The first row here, remember, this would be x plus y to the 0 because anything to the 0 is 1. So that means n is 0. Whatever your exponent is going to be the row that you use. So you might want to write this n equals 0, n equals 1, and so on your formula sheet next to your Pascal's triangle. The next thing you're going to do, you're going to have maybe an x or a y or a z on for your first term, and you're going to use that term to the nth power. So you're going to start with the highest exponent and then descend. So your first term is going to be x to the nth, and then your second term would be x to the n minus 1, and you would descend all the way to x to the 0. The second term, which is your y, you're going to start with a 0 exponent. So you'll start with y to the 0, and you will ascend up to y to the nth. Not sure you understood all that, so let's do a problem. If I want to expand x plus y to the 5th, I know there can be 6 terms because if I go down here, n equals 5, and I have 1, 2, 3, 4, 5, 6. Another way to know it is the number of terms is always n plus 1. So I know I have 6 terms, so I write here terms 1 through 6, and then my coefficients are going to come from this row. So I'm going to write 1, 5, 10, 10, 5, 1. My first term is x, but I want it to the nth power, which is 5. And then I descend, so I know my next term is x to the 4th, x to the 3rd, x squared, x to the 1, x to the 0. Now my second term, I'm going to do the opposite. I'm going to start with y to the 0, and I'm going to count up to y to the 5th. So this is a table that you're going to want to make to help you write your terms. So if I wanted to expand this, I'm going to take this table and I'm going to write the first term is going to be 1 x to the 5th, y to the 0, which is the same thing as 1, so it's going to be x to the 5th. My next term is going to be 5 x to the 4th, y. My next term is going to be 10 x to the 3rd, y squared. My next term is going to be 10 x squared, y third. Oops. My next term, 5xy4. And my last term is going to be y to the 5th. And that is one way you can use Pascal's triangle to expand a binomial.